So we're working on chapter 5, section 1, and this is day 2 where we get into the derivatives of the natural logs. So first thing I'm going to do is just define what that derivative is. So the derivative of natural log x is simply 1 over x, where x has to be positive in order for the natural log to even occur. So remember, the domain of natural log x is x greater than 0. Next up, what if it wasn't so clean and we had some function u in this? Give you an example. Maybe it was natural log of 3x squared. Well, we're going to have to invoke the chain rule on this. So pretend or assume that u is a function. And how would I deal with that? Well, it's very similar to what we did over here. It's going to be 1 over u, just like it was 1 over x. So 1 over this expression here multiplied by u prime, which really is the chain rule. So it's 1 over u, and then the derivative of the inside, the derivative of u. You could shortcut this and write it as u prime over u, and think of it that way if you wish. So mainly, it's a pretty simple, derivative, u prime over u, and I'll just walk through several examples with you so that you can get a feel for these. This is the natural log. It's the natural log of 5x. So this is kind of like that u that I was talking about. It's the function 5 times x. This is going to look like, well, remember, it's 1 over u times u prime is the derivative. So I'd have 1 over 5x multiplied by the derivative of 5x. I'll show you that. We'll take the derivative of that. That's that chain rule idea. So I have 1 over 5x multiplied by the derivative of 5x is simply 5. And that would look like 5 over 5x, but we know the 5's can cancel, so this will be 1 over x. Letter G, find g prime. And our function is the natural log of x cubed plus x. So, back again, the derivative of a natural log is, this is all our u here, isn't it? So remember, we want to do 1 over u times u prime. The derivative y prime will equal 1 over x cubed plus x multiplied by the derivative of u. So now I've got to go into x cubed plus x. We want to take its derivative. So 1 over x cubed plus x multiplied by, now let's do this actual derivative, and that would be a 3x squared plus 1. And I could write that as 3x squared plus 1 over x cubed plus x, remembering that that has the denominator of 1. I am looking to see if there's anything that would cancel from top to bottom, because I can see here that I would have an x that I could factor forward or GCF it, but on top there is not a GCF for it. Okay. When I look at this one, I notice that it's a product rule because I've got x times natural log x. So that means that we need to follow through with the derivative of the first times the second added with derivative of the second times the first. That's our game plan. So derivative of x will be, I'm going to just say y prime equals, derivative of x is 1 multiplied by the second, natural log x, added with derivative of the second. Now look back and see, what is the derivative of natural log x? Well, it's 1 over x. You could think of chain rule, the derivative of x will turn out to be just 1, so it's going to stay just as that, multiplied by the second function, which is x. I'm sorry, multiplied by the first function, which is x. Simplifying, we'd have natural log x plus x over x, or simply natural log x plus 1. The next one is a natural log on the outside, but inside I'm looking at a quotient rule. So this is going to be a chain rule. The outer function is natural log. Outer is going to be a natural log derivative, and the inner is going to require a quotient rule, isn't it? So we've got our game plan locked in our mind. Y prime equals. Well, first let's deal with the outer function. That is a 1 over, oh, you know what? Just thought of something. I think an easier approach, because this would be 1 over x, you don't have to write this down, but look at what this is going to become. And then I'm going to multiply it by the quotient rule to do the derivative of the inside, and you know what that's going to look like. This is going to get very lengthy, isn't it? And then I'm going to have, you know, f prime g minus g prime f. Very complicated. We can make this shorter, you guys, if we just utilize our properties of natural logs. So I've got the quotient of two things. That means I can divvy this up and write it as 2 natural logs. So let's do that. Natural log of x minus natural log of x squared plus 1. Look how much easier this is going to be to take the derivative. Now I'm basically taking 2 derivatives of separate terms, right? So I've got y prime equals. The derivative of this first thing, the natural log of x, is simply 1 over x. Minus the derivative of the second thing, well, in my mind, I'm seeing this kind of as my u, right? So I'm going to have u prime over u as its derivative. So it's 1 over u, x squared plus 1. And then I need the derivative of u, which is 2x. Will this simplify? No. Nothing's going to simplify there. So we have a good answer. If we wanted to write it as one fraction, we could do that. I would need to get like denominators. We'll skip that for now. Moving on. Here is the last set I think we have to do. So using log properties to help differentiate. With this square root, that could be part of the chain rule, but also if we just think about our log properties, sometimes we can make our life just a little bit easier when dealing with this. Okay, so I was saying, I got interrupted. Let's use those properties of logs, and many times we can make our problem for differentiating a little bit easier. So I rewrote this square root as a 1/2 power. Now, remember your power rule for log properties? We can bring that half down front, so we got a 1/2 natural log of 3x minus 8. This will make life a little smoother for us. Okay, so f prime of x. Well, like before, if I've got a multiplier, I can just kind of let it sit out front, can't I? So I'm going to have 1/2 times. The derivative of natural log, the outer function, is 1 over 3x minus 8. On top, because I'm in my mind, I've got u prime over u. On top, I've got the derivative of 3x minus 8. The derivative of 3x minus 8 is simply 3. My final answer, I could say, is 3 over 6x minus 16. Letter K. Was that not just the same problem we just did? Where did we do that one? X squared plus 2. We've done this. We can scratch this. We just did it. Absolute values. What if I hit a natural log with absolute value? Well, here is the description of the derivative for that one. It's simply u prime over u. No different than what the natural log of regular u is. So there's one nice thing. We don't have to memorize something different. So let's go on to problem I guess this is. Yeah. I or L, I don't know. Derivative of a natural log, I know this will be u prime over u. This inside is my u. So it's going to go to the bottom, just like it's supposed to. That will be a cosecant of 2x. On top, I need to take the derivative of cosecant of 2x. This would have been like a simple problem or a single problem on that last test that we did. This is going to require a chain rule, indeed. So, y prime equals the derivative of this top portion. Work with the outer function first, and this is my outer now, isn't it? The derivative of cosecant is negative cosecant of the inside, leave it alone, multiplied by the cotan of that 2x. Finally, stepping inside, taking the derivative of the inside will be a 2, so I'd multiply by 2. I'm going to bring that forward and put it up front. All over cosecant 2x. Hey, look at this. We will get a cancellation there, and we can simplify this just to nice negative 2 cotan 2x. Chain rule within the natural log. All right, this one looks like an interesting one, doesn't it? Okay, remember when, in my mind, I'm like, what do I do with that for? And I bet you're thinking the same thing. We got familiar with how to work with these, didn't we? Remember how we used to say this is really a sign that's getting raised to the 4th power, and we could scoot that 4 out to the edge. Indeed, we can do that on this as well. So we're going to go y equals natural log of 3x squared, all raised to the 4th power. This has 3 levels to it. Remember how we talked about, our analogy was like a hard-boiled egg. You've got the shell, you got the whites, and then you have the yolk inside. So first thing we're going to work with is the shell, which is the 4, the power of 4. So y prime is going to equal, bring the 4 down, reduce it to a 3rd power. I do it then so I don't forget to come back to that. And that took care of the shell. Now let's move to the next function inside. That would be the natural log, or what we kind of refer to as the whites of this hard-boiled egg. The derivative of natural log is u prime over u, correct? So I'm going to have multiplying, the u is this little portion, so 3x squared. And then the derivative of the inside is going to be the 6x, and that's kind of like the yolk of the problem. Okay, so simplifying, let's take the 4 times the 6x and get 24x over 3x squared. I see some simplifying there, don't you? Multiplied by natural log 3x squared, all raised to the 3rd power. And then simplify that, that's going to look like 8 over x, natural log, you could put your 3 back there if you wish, 3x squared. And that takes us to the end, which I think we have a worksheet that's going to follow.